Path 599, Hemodynamic Disorders 2. In this lecture, we're talking about the different types of thrombosis that can occur. First of all, the division that we look at is between ante-mortem and post-mortem. So mortem, or mort, means death, and ante means before, and post means after. So when we're looking at ante-mortem clots, we're looking at blood clots that happened before someone died, and post-mortem clot is a blood clot that occurred after someone died. It's my best assumption. So, looking at these clots, first of all, the ante-mortem is is dry. And so, I don't know, when you think of a dead person, you think of these, this is the way I remember it, slimy zombie, they're all gooey and stuff. And in ante-mortem, see, I'm dry right now, so you think of a dry, before they're dead, a dry, and also granular. So I don't know how you can remember granular, but dry and granules and dry granules, maybe they help you, they kind of go together. As opposed to post-mortem is going to be gelatinous, like a gooey zombie. And the next one here is that the ante-mortem clots are adherent to the vessel walls. So see this? This clot is adherent to the vessel wall. I drew a vessel here and it's stuck to the side. And that kind of makes sense to me because I'm thinking, all right, if it's stuck really hard to the side, then that means that it's not going to be loose going through and being able to clog things up. It's stuck to the side, so the person was still able to be alive because blood can flow past it. But this big gooey one over here, the postmortem, that's not well attached to the wall. I mean, it can block up the whole thing. It can move all over the place. So that wouldn't work in an alive person because it would kill them. Next, the lines of Zahn. So I don't know why it says typically the lines of Zahn are white. I don't know. Good luck with that. But in this case, so I guess the clots are white. But the lines of Zahn I drew here, they basically these lines of kind of goes back and forth between platelets and fibrins, or whatever those, fibers, and then the black erythrocytes. So, you get the platelets and whatnot, and then you get some erythrocytes, and then some platelets and erythrocytes. They're not actually oriented like this. They're kind of like going down in, but whatever. And then lastly, these ones can actually be red or white, the ante-mortem ones, red or white, okay? Which we'll get to later, just describing what the red or white means. Okay, so now a little bit more about post-mortem clots. These ones, remember I said they were gelatinous, they're not well attached to the wall. As I see, I drew them all loose here. There are no lines of Zahn, okay? I think what happened is because this person had this clot happen while they're alive, their body was kind of like going through periods of healing to keep them alive, and so like it would heal, and then there'd be the next thing would come over the top, and this is kind of like something that's been alive for a while. Whereas in this case, this happened after they died, and so there wasn't any healing that took place. It just formed a clot. There it is. There's that big clot, and sometimes the clots will be really like dark, almost like black. They call it black currant jelly. Or sometimes they'll be kind of red, so they're red or black currant jelly clots. And apparently the upper portion of these are yellow, so I drew some yellow on the top up here. And then the lower portion will be red blood cells. And I don't know exactly what that looks like or what that means or why that occurs, but you can think of like this being a container. The fat usually, if you have you take a bunch of fluids, the fat would float to the top, and then the big thick cells would go to the bottom. Maybe that'll help you think of it. So here's the yellow fat at the top, and the erythrocytes down here at the bottom. Okay, now that's one division, ante-mortem and post-mortem. But now we're going to talk a little bit about red versus white. So in red versus white, the red is what occurs in venous. Now that may seem confusing because red, usually you think of being arterial, and blue you think of being venous. But no, in this case, red is venous. And maybe as you go through it, we'll find some reasons why that might make more sense. Okay, so red venous, sites of stasis. So this is going to be places maybe like your legs, what happens in your legs is a blood vessel will become occluded or something, and it's just sitting there, and this thrombus forms, and as opposed to the other kinds, like the arterial ones, this is going to be like in areas of injury, like in your coronary artery, where there's just massive turbulence occurring all the time as your ventricles are contracting, and it's going to be an endothelial side of injury or turbulence where there's bifurcation that occurs. So with these ones, with the venous ones, they are occlusive. So you've got this stasis site like in your leg, and there's this area in your leg where the blood vessel, the vein, is occluded completely. So here I drew this guy's leg. You can see this blood vessel is enormous in his leg, but it's completely occluded, his blood vessel. And also apparently 90% of these red venous ones are going to be in your lower extremities, your legs. And what they are basically, why they're red, is because they're pretty much all erythrocytes and sparse fibrin, a little bit of fibrin in there, but mostly it's erythrocytes. This is basically just an instance where maybe you sat still for a long time and the blood vessels are just kind of like, whoa, we're not moving here, so they all just kind of stick together and kind of clot together in this big nasty red thing. That's why they happen in areas like your leg where there's maybe some stasis. We compare those. Oh, by the way, they also do have lines of sun, but they're really not prominent. They're super non-prominent as opposed to the other ones. We go over these other ones. We'll talk about this a little bit. Maybe it makes more sense. So the white thrombosis, these are typically they happen in arterial. The reason why they happen in arterial is because this is not a situation like we're in venous, where it just had stasis. In arterial, this is a situation where there's some intense turbulence that has occurred. So it's been pushing through here really fast, and that only happens in arteries, to my knowledge. So, all right, white arterial makes sense, all right? And this is going to be, again, the endothelial injury site and turbulence where there's going to be some bifurcation occurring here. And these ones are not completely occlusive, which kind of makes sense. You can already get some high pressure place here. The high pressure could probably push the clot through anyway, so it's not going to be totally occluding the thing. It's going to be kind of on the side here. And I drew this big, huge vessel coming off the coronary artery, and there's this white thrombosis here, and it's off to the side. It's not blocking the whole artery. There's still blood flow that can go through there. And I think that it happens in the coronary artery more often than it happens in the cerebral artery, and it happens in the cerebral artery more often than the femoral artery. And that kind of makes sense. You just think of what's closest. So the heart is going to be where there's the most turbulence, so that's where it's going to happen most likely. Now your head is closer to your heart than your femur is, right? So your cerebral is going to happen second most frequently. And then your femur is further away, and that's your next big blood vessel, so that's the third most common. Okay, so coronary, closest to the heart, cerebral, next closest, next furthest away is going to be your femoral, okay? And the growth is retrograde. Now I forgot to mention this in the other one. In red or venous ones, where there's a big, nasty chunk of blood erythrocytes with some sparse fibrin, the growth on these guys is in the direction of the blood flow. So it's venous, it's coming back to your heart, okay? The blood's coming back to your heart, so it's going to grow in the direction of the blood flow. So the blood flow is going this way, so it's going to grow in that direction, which kind of makes sense because you think about it, the blood on the distal side of the clot, it's still kind of moving around, right? But on everything this way, on this side, so here, let's say here's the clot right here. You can't see my legs, so I'm just going to say here's the clot. So down here, the blood can still move around and everything, right? But here, it's just sitting there because the clot's here. So everything up here is just sitting there. So it sits there, just kind of like, whoa, okay, I guess I'll form together in a big clot. So the growth continues to grow up like this, okay? So that goes in the direction of the blood flow from the clot up. Whereas these guys, the white, the arterial ones, it's going to be retrograde, okay? Which means that, so here's your heart. The blood flow is going out, okay? So let's say the clot's right here, and it's not a complete occlusion, it's a part occlusion, so some blood able to go through here. This is the way the blood flow is going. Retrograde means it's going to grow in the opposite direction, okay? The blood flow is this way. Opposite direction means that it's clotting up like this, okay? So it would be I guess in both instances it's going back to the heart. Yeah, that makes sense. Okay, so growth is retrograde, and then this one is the one that has the lines of Zahn. And lines of Zahn are basically platelets and fibrin, one layer of that, and then another layer that is dark erythrocytes. And then another layer that's platelets and fibrin, and then another layer of dark erythrocytes. So it kind of, you see there's almost like these, it almost seems like, it looks like layers of like healing, like the blood came and it got stuck to it, and then the fibrin grows over the top with the platelets, and then the blood platelets just kind of keeps doing this, and, you know, including this blood vessel. And that's all I got for that part.